Okay, so if we look at duration, obviously it's measured in this is the traditional format that we're typically familiar with when we're trying to estimate duration. However, Hopewell and Kaufman have used this type of construction in order to estimate duration. Okay, so if we go back into our spreadsheet for a moment, we could just paste that formula in. The way we estimate duration here, or would have estimated duration previously, would have used this type of format. In other words, the estimation would have been consistent with this type of construction. So if we just take this down a notch, we could see that the logic of the estimation here, where we set out the cash flows individually and multiply each of the discounted cash flows by the respective time period, okay, and then divided by the bond price, so the product of the discounted cash flows by the respective time period summed up and then divided by the bond price was equal to duration. But an alternative approach suggested here by Kaufman, Hopewell and Kaufman, relates back to this type of structure. And if we were to compare like against like, we could see this is a much simpler type of estimation. Now previously I had set out this type of structure, and again we could just point to the similarities. So if we initially had taken the Macaulay duration adopted for higher frequency compounding or payment of coupons, and we can read this as the change in the bond price divided by the change in the interest rate is equal to negative times the original bond price times its duration over 1 plus the discount rate divided by the number of time periods. Now, if we reconfigure this to just isolate duration on its own, we can by bringing the other variables across to the other side of the equal sign, and we find that negative duration is equal to the change in the bond price over the original bond price multiplied by 1 plus the rate of interest, the discount rate or yield, divided by the frequency of compounding or frequency of coupons all over the change in the interest rate. Now what we have here is comparable. The only difference, okay, the negative sign is on the other, is the opposite side of the equal sign, and instead of y here we have r, and the change in r here is the change in y is given here as change in r, and we've left out m. Or we could just, if we assumed that m was equal to 1, then we would have 1 plus r. Now we had already estimated, if I take these figures again, let's copy and put into Hopewell and Kaufman, and I'll call it 2, and just paste, and we look at this figure here. I had originally worked out, if you like, this value for duration? Well, first of all, if we manually work out a bond with these particular characteristics of a face value, coupon rate, discount rate, and time period of 5 years with semi-annual compounding, semi-annual coupon payments, where the coupon rate is equal to the discount rate, the value of the bond given by this, where we take that as being equivalent to the VBA code here, which is present value annuity factor times coupon plus face discounted for a relevant time period. Then we get a par value of the bond of 1000. And if we apply this formula here, what we can basically say is that if we increase the value of the interest rate by 0.00001, so we could, if we looked at this as 1 basis point, well, 1% would be 0.1 increase in interest rate. If we thought there was, if we wanted to represent 1 basis point, okay, expressed as a, we thought of this as a percentage. Okay, let's go back to and just convert to percentage. You can see that this is equal to 1 basis point. Okay, so if we rerun the estimation here for an increase in interest rates of 1 basis point, so if dy, change in the interest rate, dr, was equivalent to 1%, and we added 1 basis point, and we added that 1 basis point to the discount rate, the value of the bond would drop from 1000 to 999.61, relatively small drop. And we could deduce the duration by using this formula here. So let's double click and see what's there. So the change in the bond price, okay, you take the difference between these two, the change in the bond price, divided by the original bond price. The original bond price is 1000 because it was a par bond. And then we say add 1 plus the rate of interest, C5 is the original interest rate, divided by M, divided by C8, M here is 2. And then we divide that in turn by the change in the interest rate, and the change in the interest rate is the difference between these two levels, or 1 basis point, keeping in mind that this figure here is an increase of 1 basis point over the original interest rate. Now that figure we developed here is consistent with this, which in turn is epitomizes, it captures the Kaufman, Hopewell and Kaufman construction here for estimating duration. But it also, we can see that the value here estimated using this type of construction is equivalent to the duration estimate obtained using this VBA function, and that VBA function is of this format and is consistent with this type of traditional Macaulay duration type calculation. Okay, so whichever way we estimate duration, whether we use this format or we use this format, we get results that are very, very similar. So 40539 and 40529. Okay, so relatively small difference between the two, keeping in mind that the estimate that we have here is from this, or more correctly from here, And this estimate here, we could say, comes from this. So let's just copy this. Okay, and go back in. And we'll paste. And if we take this, we can say this estimation here is consistent with this, and likewise same as here. So this estimation is a manual calculation, this is with VBA, they're both the same, and this estimation here is generated by this type of construction. Okay, so let's see if we can replicate table 1. Okay, so I'm going to copy this table again, Kaufman and Hopewell and Kaufman 3, HK3. I'm going to remove what we have here, so just delete out, and I'll take away this formula, and then I'll copy. Okay, so I'll pause and I'll copy just the basic table in. Okay, so let's use the numbers again from table 1. Let's copy this and go back in and paste. And we want to set out, okay, we want to replicate the values that we had before, so we can take this away as well. And we're going to use to generate table 1. Here's our estimate for duration, and we're going to have different coupon rates, 0, 2, and I'll just fill that table in and pause. So I've set this value here, this cell here, equal to the estimation for duration using this type of construction. I want to consider different coupon rates and different time periods, similar to table 1 of Hopewell and Kaufman. Let's highlight everything. Go to Data tab, What If Analysis, Data Table. On the column we have the time period, so we're going to use T here. Now before I do this, I need to make sure I'll set out the same values that I had before. So let's go back to Kaufman Hopewell here, and we'll just copy and paste. So copy and paste in, so paste, and likewise we need to change the time period back 3, and just look at our values for a moment. Coupon rate being the same. Okay, and so we have a value here consistent with the value we had estimated before, so 2.789. okay, and let's run the data table, and we'll set the coupon rate same as here, and we must set the time period same as here, because those are the two that I'm going to adjust. And then I'll run the data table, so data table, data tab, what if analysis, data table. On the row we have the coupon rate, on the column we have the time period, and it fills in very quickly, and we can verify the results are the same, broadly speaking, as what we have over here. Okay, so let's just, and you can see the results here are broadly in line. If we, somewhat different, but broadly speaking, very, very similar to the values we had observed before. take it down to 3 decimal place.